All right, so we have 3 points, OAB, and where O is the origin with coordinates 0, 0. So we're talking about the origin being the center there, where both axes cross. So this is their x-axis, this is our y-axis, right? Coordinates of A, we go down to the x-axis, that -2. So that's the x component is -2. All right, always the x component first. So location is -2, go to the y is 4. For point B, we go down to the x-axis, that's 3. On the x-axis and on the y-axis is also 3. So that's 3, 3. In terms of the position vector of A, written as position vector OA, vectors, we have this arrow on top, and since it's a position vector, we start from the origin O. So it's OA, so going from O to A. So notice that we go the x direction first, right? We want to go from O to A, we're going to go 2 to the left and 4 up. So that's going to be 2 to the left is -2, right? Once you go to the left is -2. I'm going up. So once you go to the left is negative, I should say. Once you're going up is positive, so that's a positive 4. But notice that the components, all right, are the same. So then in terms of the coordinates of A, -2, 4, and the position vector OA uses the same values, but just written as a column vector x, y. All right, so based on that principle, OB, we just need to know the coordinates for B. And we have the coordinates for B already, which is 3, 3. So we're going to simply write it as 3, 3 as column vector. All right, this has to do with position vector. You must start from the origin for this to happen. Okay, well, we can check it out. From the origin, we're going to go 3 to the right, positive 3, and then going up, positive 3 as well. Easy stuff. Now express the vector AB as a column vector. So how we do this? Now this one now is not a position vector because we're going to start from A and go to B. So we're starting from A here. We're heading over to B. All right, so we're going straight ahead there. So there's several ways we can do it. We can do it graphically, or we can use the triangle law, all right, of vectors. So there's several ways to do it. If you want to use just the position vectors only and not change their signs, this is what you can do. You're going to start with the last letter, which is B. So you're going to use the position vector OB, right? Because we're starting the last letter, so we're going to say OB. I'm going to use subtraction. Because we're starting with the last one, we use minus. And we're going to use the first letter now, which is the position vector of it, by the way. All right. And notice that we kept it as position vector minus position vector, but it's going to be the last minus the first. That's why they say the first should be the last, and the last should be the first. But make sure you use minus. All right. And then we're going to enter our values, right? It's 3, 3 for the position vector OB, and OA is -2, 4. And to do this is going to be, now to subtract this is 3 minus -2. When you have 3 minus -2, you're going to get 5. And 3 minus 4, that's -1. Calculator can do that trick, okay? So 3 minus -2 become a positive, that's 5. And 3 take away 4, a small number taking a bigger number, so it's to be a negative. All right, now it says to calculate the magnitude. Magnitude means the length of vector AB. So just pay attention to the fact that vector AB, right, has components x and y. The x component is 5, the y component is -1. And so we can find the length of vector AB this way: the square root of x squared plus y squared. All right, the x component, as I said, is going to be 5, so we're going to square that. And the y component, we're going to square it, which is -1. Now, when we square the 5, we get 25. So this is equal to the square root of 25. And when we square the -1, it's +1. This gives us square root of 26. And when we put that in our calculator, we get 5 point. No, they said to 2 decimal places, right? So in my calculator, it's showing, let's put it at the top here, 5.099 etc. Right? We only want 2 decimal places, mean 2 digits after the point. Now think of this as 5,099. If you're rounding this, all right, you want 2 decimal places. You want these, right? Well, not 2 decimal places, but if you want the first 3 digits, I'll chop off the last one. It's 509 you have here. But if you add 1 to it, what would you get? To 509, you get 510. So this is exactly what the answer should be, 5.10. All right, hope that makes sense. So the idea is that we're gonna add 1 to this. We're gonna chop this off here because we only want the two decimal places. And we're gonna add 1 to the 9. All right. So in fact, we're really adding 0.01, really, because the 1 is added to the 9. The 1 plus 9 is 10. 1 plus 0 is 1. But by the point, 5 plus 0 is 5. So 5.10. So this is actually 5.10 units. 2 decimal places. All right. Now, let's say we want to calculate. Let's say given that LM, vector LM, that says, is equal to 15, 13. Well, 15, negative 3. Right? A vector. By calculation, prove that vector LM is parallel to AB. Well, what is AB? What did we get for AB? We got 5, negative 1. Now prove that they are parallel. To prove that they're parallel, mean that they one is a multiple of the other, right? And so if we look at LM here, let's look at LM. Is 15, negative 3, which we can write that if we were to factor out the 3, right? Because 3 times 5 is 15, and 3 times negative 1 is negative 3. Because 3 is inside. Let's look at it this way. 15 can be written as what? 3 times 5, right? And then the negative 3 can be written as 3 times negative 1. So 3 is a common factor, basically. So we've seen that positive 3 is common in both. And really, this is LM, by the way. So we can just write back LM here is equal to 3. Now, what vector is this? What vector has this column vector? That's AB. AB has this component. The component is 5, negative 1. So instead of writing like this, we can actually write what AB is itself, right? Write AB itself. So we've seen that LM, vector LM, is a multiple of vector AB. It's 3 times the length of vector AB. Now, once two vectors, one vector is a multiple of the other, it means that they are parallel. And they share no common point in terms of LM and AB. So it means that they're parallel. Right? So we can say therefore vector LM is parallel to vector AB. Since LM is a multiple of AB, vector AB. Proven, right? All right, and so I think that's it.